Okay, so if you look at, they have the directions right here for the 4 steps. So the 4 steps that we're going to do, again, this section is called solving a system of equations. So you're going to have 2 equations with 2 unknowns, and the method is called elimination. So we're going to try to eliminate a variable. So the first thing it says is line up the variables. The second thing is we're going to add the 2 equations together so that one of the variables cancels out. All right, we're going to eliminate one variable. Then we're going to solve for the other variable, and then in step 3, we're going to plug that solution for one of the variables. We're going to plug that into one of the 2 original equations and solve for the other variable. And then in step 4, we're just going to write our answer as an ordered pair, x comma y. So let's go ahead and look at example 1. All right, could you guys see that in example 1 that the variables are lined up? So what you got is vertically the x's are lined up, and the y terms, those are also lined up. And then the constant term, just these numbers, are also lined up. So then you may want to note that both of these equations are in standard form. This one is ax plus by equals c, and this one is also ax plus by equals c. So in this case, a would be 1, b would be 4, and c would be -2. So this elimination method is a method that we're going to use most of the time when the 2 equations are given in standard form. Well, can you guys see right now if I add together the -4y plus the 4y, that would be 0y and it would cancel out? So what we're going to do then is we're just going to add these equations together. So we're going to add them together right away. So if we add them together, we have 3x plus 1x. That's going to give us 4x. The y's are going to cancel out. The -4y and the +4y, those cancel out and make 0, so the y's are eliminated. And then we're just going to add together the right-hand side. So on the right-hand side, we have 10 plus -2, which is 8. Then we're just going to divide both sides by the number in front of the variable. And we're going to get x equals 2. Well, now we still have to go back and find y. So we can take that x equals 2, and we could plug that in for this x right here in the top equation, or we could substitute in x equals 2 into that bottom equation right there. So I think it would be easier if I substituted in the bottom equation. So I'll rewrite the bottom equation for you guys. That one was x plus 4y equals -2. Hold on, I gotta let some people in real quick. Okay. But not saying you need to turn your camera on also. Okay, so where was I? So I rewrote the bottom equation, and now we're just going to take that x equals 2, and we're going to plug it in or substitute it in for that x right there. So then that would give us 2 plus 4y equals -2. Then we would just subtract 2 on both sides. And we would get 4y equals, on the right-hand side, we have -2, take away 2 more. Hold on, I'm letting more people in again. So on the right-hand side, we'd have -2, take away 2 more. That would be a -4. Then divide both sides by the number in front of the variable. Let me slide down here for you guys. And those 4s would cancel out on the left-hand side and make a 1, and we get 1y is equal to negative 4 divided by 4 would be negative 1. So then again, the last step is they want us to write our solution as an ordered pair. So the ordered pair for this one would be x is 2, comma, y is negative 1. So there you go. There's your first solution. Now remember what this solution means. That means if you plug x equals 2, y equals negative 1 into both of these original equations, both of those equations would be true at the same time. Also, if we graphed both of these equations, the original equations, they would both graphs would be a straight line, and this point 2 comma negative 1 is where those two lines would hit each other, or where they intersect. All right, let's move on and do another example. Again, if you guys have a question, just unmute your mic and just give me a shout out and I'll stop, okay? So let's do, I don't know, which one should we do? Let's try number 3. We don't need to do all of them. So number 3. Can you see right now on number 3 that if I add those equations together, nothing will cancel out? Because if I add 2x plus 2x together, that's going to be 4x. And if I add positive 1y minus 5y, if I add a positive 1y and a negative 5y, that's going to give me negative 4y. So none of the variables would be eliminated. So what I need to do is I need it to look like this. If I have 2x in the top equation, then below it I need to have negative 2x in the bottom equation so that those will cancel out and make 0. So what could I multiply the bottom equation through by so that the x's would be eliminated? One of you guys can unmute and tell me. What could I multiply the bottom equation through by so that the x's would cancel out? Again, Kennedy and Vanessa, you need to have your cameras on. And Jaden, I can't see you. I didn't see you yesterday either. All I got is a blank screen on you.
Yeah, I have my video going, but nothing pops up. Like when I stop the video, it looks like that, and then when I have it going, it looks like that.
I got you. Well, just check it. That was good that you checked in with me, though. I know you're there. So anyways, my question is, what do I multiply that bottom equation through by?
Negative 1.
Very good. Thank you. So we're going to multiply the bottom equation through by negative 1. So negative 1 times. Now, don't forget, I'm multiplying the left side by negative 1, and I'm multiplying the right side by negative 1. So you're going to need to distribute that negative 1. Anthony, I'm getting some kind of noise out of your room there, okay? So I'm going to distribute this negative 1. And then the common error is people forget to multiply the negative 1 times the 13 on the right side.
You're multiplying negative 1 because of the y, right?
No, because I want the x's to cancel out. Watch what happens. So the top equation is going to stay the same. So the top equation is going to stay as (2x plus y equals negative 5. Now the bottom equation, I'm going to do negative 1 times the 2x. That gives me negative 2x. And then I'm going to do negative 1 times the negative 5y. That's going to give me a positive 5y. And then don't forget to do the negative 1 times the 13, which gives me a negative 13. Now you should see that when I add the equations together, the x's will be eliminated. So now if I add 1y plus 5y, that gives me 6y. And on the right-hand side, if I add negative 5 plus negative 13, negative 5 take away 13 would be negative 18. Now just divide both sides by whatever number's in front of the variable, and I get y equals negative 18 divided by a positive 6. That's a negative 3. All right, now I need to go back and find x. So I can take that y equals negative 3, and I can put it in for y in the top equation right there, or I could substitute it into the bottom equation right there for y. I think it would be easier to put it in the top equation, so I'll use that one, but it doesn't matter. You can use either one. So I'm going to rewrite the top equation. So 2x plus y equals negative 5. And I'm going to take the y equals negative 3 that I just found, and I'm going to plug it in right here for y. So then that's going to give me 2x plus negative 3 equals negative 5. Well, that's the same thing as 2x minus 3 equals negative 5. So then I'm going to add 3 on both sides. The 3's cancel. I get 2x equals negative 5 plus 3 is negative 2. Divide both sides by the number in front of the variable. The 2's cancel out, and that leaves me with 1x equals negative 2 divided by positive 2. That's a negative 1. And if you wanted to check your solution, you would plug x equals negative 1 and y equals negative 3 into both of the original equations, and both of those equations should be true. But to wrap this up, let's write our answer as an ordered pair. So the x would come first. That would be negative 1, comma, and then the y solution was, the solution for y was negative 3. All right, any questions on that one? Let's do one more. So let's do number 5. All right, so number 5. Now, can you guys see on number 5, if I add the x terms together, nothing is going to cancel out. And if I add the y terms together, nothing's going to cancel out either. 2y plus 1y would be 3y. So in this one, you guys have to decide, do you want to eliminate the x's or do you want to eliminate the y's? So you guys can unmute, tell me your choice. Hold on, I gotta let somebody back in. So what do you guys want to do? You got to make a choice. Eliminate x or eliminate y. It doesn't matter.
X.
All right, we're going to eliminate x. Well, to eliminate x, we're going to need something like this. If we have a negative 3x in that bottom equation, we would need a positive 3x in the top equation, so that when we add them together, we want them to cancel out, right? So what we're trying to do is we're trying to get the number out in front of x. That's called the coefficient of x. We're trying to get those to be the same number, but opposite signs, okay? One of them positive and one of them negative. So what could I multiply the top equation through by so that I'll end up with a positive 3x?
Times 3.
That's good, thank you. Yeah, so we're going to multiply the top equation through by 3. Okay, so 3 times the top equation. And again, we're going to distribute that 3. And then don't forget that we are multiplying the right-hand side by 3 also. Okay? So we're multiplying the left and the right sides by 3. All right, so then I guess I'll come down below here. So now my top equation is going to become 3 times x, that's 3x. 3 times 2y, that's going to be plus 6y. And that's going to equal 11 times 3. Again, that's the common mistake. You forget to multiply the 11 by 3. That's going to be 33. And then the bottom equation, I'm just going to leave it as it is. So negative 3x plus y equals negative 5. Now I'm going to add the equations together, and you guys should see that the x's cancel out, so the x's are eliminated. That's why this method is called the elimination method. So then I'm going to add the y's. So I got 6y plus 1y. That gives me 7y. And that's going to equal 33. Take away 5. That's going to be 28. Then we're going to divide both sides by the number in front of the variable. And we're going to get y equals 4. All right, now we're going to take that y equals 4 and we're going to plug it into one of the 2 original equations. So we can plug y equals 4 in for this y, or we could substitute it in the top equation for that y. But I think it looks easier if we put it in the bottom equation. So I'm going to rewrite the bottom equation. That one was negative 3x plus y equals negative 5. And I'm going to take that y equals 4 that we just found, and I'm going to plug it in right there for that y. So that's going to give me negative 3x plus, I won't put it in parentheses this time, I'm just going to plug in 4 for y. And that would equal negative 5. Then I'm going to subtract 4 on both sides, and I get negative 3x equals negative 5, take away 4 more, that would be negative 9. Then divide both sides by whatever number's in front of the variable. And we get x equals negative 9 divided by negative 3, that would be a positive 3. All right, so our solution then as an ordered pair, the x comes first, that's going to be the point 3, comma, and the y value is 4, so 3, comma 4. You guys got any questions on that one? So let me, let's do one more. Let's try to do the story problem. Hold on, I'm gonna grab my, let me turn around. Let me grab a water real quick. I'll be back in 1 second. Okay, I'm back. So let's do the story problem. So let me see if I can fit that on the screen for you guys. That's probably about the best I can do. Okay, so in this story problem, it says Paige wants to buy 12 sheets of felt and cardstock. And then she's got a total of $7.75 to spend. So to start this, it's going to look something like this. It's going to be the number of sheets of felt plus the number of sheets of cardstock is going to equal 12. All right? So that's sheets of felt plus sheets of cardstock equals a total of 12 sheets. All right? But then the second equation is going to have to involve the amount of money that she wants to spend. So it costs 50 cents for each sheet of felt. So 50 cents for each sheet of felt plus 75 cents for each sheet of cardstock. And that's going to equal the total amount of money that she's going to spend, which is $7.75. So let's make a little note here. The C, that's the number of sheets of cardstock. Okay? And then the F, that is going to be the number of sheets of felt. So that's what the F is. All right, now we got to try to solve that system. We got a system of two equations with two unknowns. So right now, if you look at this, well, first of all, take note that bottom equation is definitely a money equation, right? Because if you do 50 cents times the number of sheets of felt, that's going to tell you how much money she spent on felt. And then if you do 75 cents times the number of sheets of cardstock, that's going to tell you how much money she spent on cardstock. And then that has, when you add those together, that has to equal the total amount of money that she spent, which is $7.75. All right, so then what we really have here is we have, this is a 1 and this is a 1. So what we want to do is we want this to look like, let's say we're going to eliminate the F's. Well, then we're going to want 1F on the top and negative 1F on the bottom so that they will cancel out. So my question is, what would you multiply the 0.50 by so that you get a negative 1? So 0.5 times what would give you a negative 1? Remember, 0.50 is the same thing as 1/2. So 1/2 times what would give you a negative 1? If you know the answer, you guys can unmute and answer.
Negative 0.5.
Well, you could do, if you did 0.5 plus 0.5, that could get you a 1.
Is it -2?
Yes. Yes. You got to multiply by -2. You got to think it's like, you got 50 cents, so you want to double that to make 1, right? So if you want to think of it that way, 50 cents, if you double that, you get $1, right? So it's a -2 that you actually need. So we're going to multiply the bottom equation through by -2. So maybe I can move this over a little bit. So this is going to be a -2. So -2 times the bottom equation, that's going to give you -2 times 0.50, that'll give you -1F. And then -2 times the 0.75, that's going to give you -1.50C equals. And then if you multiply the right-hand side by -2, -2 times 7 75. That would be what, negative 1550? So negative 15.50. And then the top equation, we're just going to leave it alone. So the top equation is 1F plus 1C equals 12. Now we're going to add the equations together. And you guys should see that the F's cancel out. So we eliminated the F's. Then we're going to do 1C take away 1.5C. That's going to give me a negative 0.50C equals. And on the right-hand side, we're going to do 12 minus 1550. That's going to give me a negative 350. Then we're going to divide both sides by the number in front of the variable, which is a negative 0.5. And these will cancel out, and I'll get C equals, that should be 7, positive 7. Now the question was, how many sheets of each should she buy? Well, that means she's going to buy 7 sheets of cardstock, because C represented the number of sheets of cardstock. And then we need to plug that back in and figure out the number of sheets of felt that she's going to buy. Well, I think you can see that if we take 7, that's our value for C. So we're going to take 7 and we're going to plug it in right there. Here, let me take those ones off of there. Oops. Well, you guys should be able to do this, right? What number plus 7 equals 12?
5.
Yeah, it's got to be 5. Thank you. So F here is going to have to equal 5. Because 5 plus 7 would have to equal 12. So that means that F is going to equal 5. So that means that she's going to buy 5 sheets of felt. Well, I think that's probably enough for today. We are going to fill this table in at the bottom of the page there. If you look at that table and then it continues on the next page. We are going to fill that in, but I think we'll wait and we'll fill that in on when I see you guys again on Thursday. Okay? Basically, we learned 3 methods to do the same thing. The first one, we graphed both equations and we found the point where the 2 lines intersected. And then yesterday we used the substitution method, and then today that was the elimination method. But we'll talk about summarizing each of those methods. We'll do that on Thursday. Let me stop the recording real quick here.